In this video, we'll have to find the maximum node of a single linked list. That means you'll have to find the node whose data part contains the highest value, and you'll have to report this value. This highest value, you'll have to report that. So what I mean is, if I have a linked list, let's say I'm drawing the shortened version of a linked list. So let's say I have a linked list called 3, 7, 2, 4, 1. So if I have a linked list like this, so all these values represent the data part. These values represent the data part, okay, data part of a linked list, data part of every node of a linked list. Now, if I'm given a linked list like this, then my output against this function will be 7, which is the maximum value. 7 here is the maximum value of my linked list. So my output will be 7. Okay, so now with this in mind, let's proceed to write the function. So you need to first define the format of a linked list. So I guess if you look at my previous 3 or 4 videos, you will find how a node is defined, right? The format of a node is defined, so you can go through that. And anyway, I would suggest that you go through the previous videos before watching this. Otherwise, a lot of nitty-gritties will not be clear to you. So I would suggest that you go through those videos first and then come back to watch this. Okay, you'll find the links in the description below as well as in the information bar present at the top right corner of your screen, which is probably showing up right now. Anyway, now let's directly go on to write the function. So I need to find the maximum node. What I'll do is I'll make this function return the maximum value. So I'll just erase the question. Okay, I need some extra space for this. This will be a slightly longer function. So what I'll do is I'll just erase the question. I hope you've copied it down. If you haven't, please rewind the video and copy down the question. Now what I'll do is I'll start writing the function. So I'll assume that the return type of this function is int. So I'll say int, and I'm calling this function maximum. I'm calling this function maximum, and this function will take an argument as a linked list. So how do I pass an entire linked list? I'll pass the head pointer. Okay. Now, the first thing that I need to check is the list actually containing any node? So how do I do that? In order to do that, what I'll say is I'll have a condition. So I'll say if h is equal to null. So if h happens to be null, that means my list is empty, right? My list is empty. So if h is equal to null, I'll simply print out. So I'll say printf. So what I can do is, just for ease of explanation, I'll make the return type of this function void. Okay. Then I think it will be easier for you to understand as well. So I'll say if the linked list is empty, then the linked list is empty, right? So I'll simply print out the statement list is empty. Okay. I'll simply print this out. Now, what if the list is not empty? Then what do I do? So if the list is not empty, then I need to implement the logic of finding the maximum number in a list of numbers. So what is the logic? I'll assume the first node, the data part of the first node, to be the maximum value of my linked list. And now I'll start from the second node. I'll keep comparing every node's data part with my assumed maximum. If I find a data part of a node to be greater than my assumed maximum, then I'll change my assumed maximum to be the new maximum. And what is this new maximum? This new maximum is the data part of the node which I'm currently accessing. Okay, you just pause the video for a moment and you rewind it. You rewind the last 30 to 40 seconds and just see it 2 or 3 times what I said. Then I think the logic will be clear to you. Okay, so using the logic which I just pointed out, I'll move on to write the function. Now, of course, I'll have to traverse the entire linked list. So I need a pointer because I'll never move my head. So I'll say struct node star ptr is equal to h. And I need another variable as well called max, which will store the maximum value. Now what I'll do is, so if the list is not empty, then definitely it contains a few nodes. So I'll come to the else part and I'll assume. What will I assume? I'll assume that my maximum value is the first node, right? So currently the first node is being pointed to by ptr. So I'll take the address, I'll take the data part of the first node and I'll store it in max. This is my assumed maximum. This is my assumed maximum. Now I'll start the check from the next node. So how do I move on to the next node? So in order to move on to the next node, I'll simply say ptr equal to ptr arrow link. This will take me to the second node if there exists one. So I'll move on to the second node and now I'll simply run a loop which will enable me to access the entire linked list. I mean the rest of the linked list. So I'll say while ptr is not equal to null, now I'll check if my assumed maximum, or let's say if my current data part. So if the data part of the current node, how do I get that? I get it through ptr. So if the data part of the current node to which ptr is pointing, if that happens to be greater than my assumed maximum, what will I do? I'll simply update my maximum. To reflect the change. So if ptr arrow data is greater than my current maximum, what is my new maximum? ptr arrow data. That means the data part of the current node to which ptr is pointing. If that happens to be greater than my assumed maximum, my maximum must be changed. To be the data part of the node to which ptr is pointing, since it's greater than my current maximum. So after I do this, what do I need to do? I need to move on to the next node. So how do I move on to the next node? In order to move on to the next node, I simply say ptr equal to ptr arrow link. This will take me to the next node. So in this way, I'll be able to traverse the entire linked list. Now after I'm done with the entire while loop, I'll simply print out the maximum value. So how do I print out the maximum value? I say printf. Now \n will take me to the new line. So maximum max value is equal to %d, and in place of %d, I'll simply substitute the value of my variable max. Right. So this will bring an end to the else block, and this will bring an end to the entire function. Okay. So this is what it is. Now what I'll do is I'll not stop here. I'll do a dry run. Let's do a dry run against this. Let's say I have a linked list. Let's have a linked list containing 4 nodes. Okay. So this node contains 3, this contains 7, this contains 12, this contains 15. I'm not showing the addresses now. Just I want a quick dry run. So I'm not showing the addresses. This will be really fast. Now see, so I'll take 3 possible scenarios. This is scenario number 1, when the list contains multiple nodes. I'll take scenario number 2, where the list contains exactly 1 node. And I'll take scenario number 3, where the list is empty. That means my H is null. Okay. So let's see. Now currently H is pointing to this node, right? H. So I'm dealing with scenario 1 now. Now, as I saw that H will receive the head pointer of the list. So H is pointing to the first node. Now I'm saying struct node star ptr equal to H. That means ptr is pointing to the same node as H. H is pointing to this node. Ptr is also pointing to the same node because struct node ptr is equal to H. Now max. Now I have a variable called max, which currently contains an unknown value. Now I'll check if H is equal to null. Is H equal to null? No, because it contains the address of this node. So I'll come to the else part. Now else part tells me max equal to ptr arrow data. So what is ptr arrow data? See, the data part of the node to which ptr is pointing. Ptr is pointing to this node. Its data part is 3. So take that value and assign it to max. Now ptr equal to ptr arrow link. Ptr arrow link means the address of this node. So I'll take ptr to this node. So now ptr is pointing to the next node. Now I'm checking. While ptr is not equal to null, of course ptr is currently containing the address of this node and it is not equal to null. So you come inside ptr arrow data. So data part of the node to which ptr is pointing. What is the value? 7. Is it greater than my maximum? Yes, it is. So you come inside and you say max equal to ptr arrow data. Ptr arrow data is 7. So now max will become 7, as it should be, because after seeing these 2 nodes, the maximum is 7. Now next what will I do? I'll say ptr equal to ptr arrow link. So ptr will move from this node to this node. So now ptr is pointing to this node, right? Now again I'll go back up to the loop. Obviously this condition is satisfied because ptr is not equal to null. It is containing the address of this node. You come inside ptr arrow data, that is 12. Is it greater than max? Yes, it is greater than max. That means I need to update my max to 12. So I'll update my max to 12. And after updating the max, I'll say PTR equal to PTR arrow link. So now PTR will move from this node to this node. Again, while PTR is not equal to null, indeed PTR is not equal to null. So the condition is satisfied. You come inside. Now you check. The data part of the node to which PTR is pointing is 15. Is it greater than max? Yes, it is greater than max. So I need to update my max to PTR arrow data. So max becomes 15. Now what do I do? PTR equal to PTR arrow link. So PTR arrow link is null. So that would make PTR to contain the value of null. So PTR is currently pointing to no node of this linked list. Now again, I'll go back up. This condition is no longer satisfied. So I'll come out of the loop and I'll print the maximum value as max. What is the maximum value? 15. Now look at this list. Indeed, the maximum value is 15. The maximum value from this list, you can see it. You can see it visually that the maximum value is 15 and the function also returned a value of 15. So I guess scenario 1 was understood. Now let's take up scenario number 2. In scenario number 2, what is the possibility that we get the correct result? So scenario number 1 is over. So scenario number 1 is over. Now scenario number 2 tells me that I have a linked list with exactly one node, which is 3. Now H is pointing to this, obviously, and PTR is also pointing to this. Now look at this. This condition is not satisfied because H is containing the address of this node, which is not null. So come to the else part. Max equal to PTR arrow data. So max, PTR arrow data means the data part of the node to which PTR is pointing. So PTR is pointing to this node. Its data part is 3. Max gets a value of 3. Now I'm saying PTR equal to PTR arrow link. Now PTR arrow link means the link part of this node to which PTR is pointing. PTR is pointing to this node. PTR arrow link means take the link part of the node to which PTR is pointing. So the link part of the node to which PTR is pointing is null. So PTR now becomes null. As a result, PTR is not pointing to any node. Now this loop will start while PTR is not equal to null, but PTR is equal to null. So the condition is not satisfied. So you'll directly come to this printf part and you'll print the maximum value as 3, which is indeed the case. If I have exactly one node in my list, then the data part of the node will be the maximum value. Now let's look at scenario number 3, if H is equal to null. Now this is the most trivial scenario. You can see that H is equal to null and I'll check, right? So struct node star PTR equal to H. So PTR also gets a value of null. PTR also becomes null. Now if H is equal to null, indeed H is equal to null. So I'll simply print list is empty and it will not come to the else part. It will directly end the function. Okay. So this is how this function would behave in all possible scenarios. I hope you have understood this. If you have any doubts, please feel free to leave them in the comment section below. I hope this helps. Thank you.